Well, hi, good morning, and thank you so much for joining me here in my shop. Today is the last day of August 2023, and again, it's another beautiful day here. The last couple of days I really haven't been able to bring myself to spend time in the shop here. Today is no different. It's going to be complete sunshine, starting out 14 degrees, which is quite cool, very fall-like. And only going up to 21 today, but complete sunshine all day. Fantastic. Why am I in my shop? Because I would like to make some kind of progress here, and I'm really not sure what to do next. I had not found a schematic or alignment instructions for this radio. So one of the things I've noticed, I'm just thinking about alignment for a minute here. Here, let's go up in the world. So I notice there's a trimmer capacitor right here. You can see the screw for it. And then there's another one mounted here. And this one is mounted, well, looks like it's just attached to one of the terminals here, to the stators of the capacitor, and the other side clearly is just going onto the frame of the capacitor, and the frame is riveted solid to the chassis. So the first thing I would think is, well, it's one of these two trimmer systems where one trimmer is in parallel with the trimmer capacitor, and the other one is in series with it. Not the trimmer capacitor, the actual tuning capacitor. These capacitors, they come in two styles. One is both sides look exactly the same, and another style is one side's plates are smaller than the other. This one is smaller than the other. If you look here, you can see it quite clearly. This is smaller than the other. This would be the oscillator here. And my understanding is when these plates are smaller, you don't require the second trimmer capacitor, the one that's in series. But what's this doing here? Why is this here? I don't know offhand. Again, if I had a schematic, I could probably look at it and probably reason out why it's here, but I don't know why it's here right now. And of course it has a capacitor, not of course, but it also has a capacitor. This is obviously to tune the antenna. Well, I think so anyway. That's what it looks like. So that's just a little peek ahead at trying to figure out how to do the alignment without instructions and not get all bunged up. So I really would have to try to find out what this is at some point. Now, let's look underneath here. Okay. So all I've done under here so far is change the power supply capacitor. So it's nice new ones. Definitely improved the operation of the radio, no doubt about that. Eliminated the garbled sound, or what I believe is intermodulation, distortion. They like to use the word distortion there. Almost sounds more like interference to me, but okay, here's an idea. I have an idea. We'll start changing out these capacitors here. Not too many of them. And my idea is to find out what happens if one of these capacitors were to be completely open circuited. Now, they probably aren't. Oh, there's another one hidden here. They're probably kind of okay. That would be my guess. The critical one would be the grid blocking capacitor on the output tube. And did I not discover somebody had changed it already? Or am I just confused? I've become confused. I've done too many similar radios. So here it is here. So this is coming from the volume control over to the detector tube preamp. Then it's going to come back, probably in this capacitor, back to here. I'm not sure. I'm just guessing though. So maybe this is the grid blocking capacitor. Why don't we find that out? Let's focus in on that first. The grid blocking capacitor, if it's a little bit leaky, can impact the operation of the radio. Many of these others, if they're a little leaky, it's not really the end of the world. Because these leaks I'm talking about are actually very small amounts of charge is leaking through these capacitors. Okay, so we would start with the output tube, which is where? Right in the middle there. It's definitely this one. And was a 35L6, was it not? A 35L6. Or was it a 50L6? Would they be any different? A 6L6 is certainly different from those. 6L6 is a very special tube. 35L6. Here we are. Probably exactly the same as a 50L6. Let's see. If it is a 35L6, then, well, where's the grid? We can find the grid. Grid G1 is on pin 5. So we'll count 5 pins here. See where we end up. Here's the key. So 1, 2, 3, 4, 5. This guy is the grid. That's the grid blocking capacitor right there. That be him. Okay, so to do this experimentally, what we'll do is we'll play the radio, we'll measure the grid voltage here, see what it is, see if it's what it should be. Now wait a minute, something else. We also need to know about how this is biased. It's almost certainly biased with a cathode resistor. So rather than push the grid negative, they decided to elevate the cathode positive. 35, yeah, don't close the book, Jim. Why do you keep closing the book? 35W4, what? 35L6. Looks like I'm going to lose another page here very soon. Now this book was given to me in, would have been 1978, by a fellow I was working with. He was older, close to retirement. He was working in a power company, nothing to do with vacuum tubes. Well, actually they had equipment with vacuum tubes in it still. Nothing to do with me though. And he just came in one day and handed me this book and said, here, maybe you'd like this, because he knew I was fooling around with vintage radios. Yes, these radios were old even then. These radios were old when I was 5 years old. These were old radios already. Holy smokes. I'm not 5 anymore. Gave me this book, said, hey, maybe you'll make some use of this book. And I've used this book since I've been doing this work. Virtually every day of the week I'm looking in this book. Yeah, so thank you very much. His name was Hugo Oja, O-J-A, but I'm afraid he retired and passed away very quickly. Another important lesson to me I learned from him, and a few others who worked long careers, retired, and then were gone within just a couple of years. Jeepers. Isn't that a sad thing? Okay. Now, getting back to what I'm doing, stop reminiscing. So, grid, so 5, so plate, so cathode, Jim, cathode. Pin number 8 is the cathode. So we trace from 8. It's coffee time already. Already? I just barely got going. I must follow the rules though and go for a coffee. Let's find pin number 8 is right here. Pin number 8 is hooked up to this wire. This is a little odd. Usually the cathode resistor is right on the terminal. So we're looking. Way the heck over here. Way over to here. Oh my, that can't be the case. Can't be the case. Let me get a better look at the wire. First of all, let's double check and make sure. Yeah, this is... No, that's not pin 8. That's the whole problem. This is pin 8. There's the resistor right there. This is going to be like 150 ohms or something of that sort. Let's take a read. First we'll drop some things on the floor. So I think this is going to be be around 150 ohms. Oops. 175 ohms. The color code, it's body and dot. So it's brown and then yellow. So that's 1, 7, and then the dot, which either we can't see or it's brown also. And you can't see brown on brown. So that would be 170 ohms. It's reading 175. There's nothing wrong there. Perfect. That's good. So the real question is this guy leaking a charge over onto the grid? Wait a minute now. How can this be the grid? There's a resistor going to the on-off switch. I assume this must be a B minus point back here. Okay, no more sticking your fingers in there, Jim. We're going to turn this guy on. We're going to read the voltage there. I'm going to use, I can use this meter. It's sitting right here. Okay, here we go. Is everything ready? Volume is down. Switch is on. Power is gone. Dim bulbs went on and off. Too quick to see because you weren't looking. You weren't looking. Now, here it comes. We will take a look. We want to look at the voltage basically across the resistor first. That's going to show us the bias voltage. Ooh, not in the ohm setting. Jimmy. See, the coffee alarm went off and I didn't pay attention. We'll put it on 60 volts there. Across the resistor, cathode should go positive. 6.5 volts sounds great. Now, we'll look at the grid. The grid we want to read also to B minus. Let me read the same point here. This must be a B minus. It says weekly. There's 1 volt sitting there, positive. Should read 0. The voltage that the capacitor is blocking is probably around 50-60 volts, 40 volts. Supply voltage to the radio is 104. Yeah, so it looks like that capacitor is leaking slightly, causing an elevated grid voltage. So what we're doing here is we're elevating the cathode. Here's the grid and cathode. Elevating the cathode. Now the grid appears negative relative to the cathode. That's what we need to make the tube operate. But what's happening is the grid is being pushed positive, a volt. So ultimately the difference here is only 5 volts instead of 6.5. Well, what does the book say even though I closed it again? 35Z5. 35L. 35L6. There we are. What does the book say? The book says typical operations, grid number 2. Grid number 1, control voltage minus 7.5. For cathode bias, 180 ohm resistor. So it's right in the ballpark, isn't it all? Perfect. So we need that extra volt. We got to get rid of this leaky capacitor. That'll be job number 1. So let's cut it out of there. My parents used to say that to me a lot. Cut it out. A lot. They said that a lot. You know what else my parents said to me a lot? Maybe in the middle of making some sad excuse. Oh, baloney. I wouldn't be able to finish my sentence. No negotiations with my parents. they were rulers, and I better do as I'm told. That's the world I came from. This is I can't read it just with my eyes here. It's too gummy. Let's put the all-powerful magnifier on it. And the number is 0.01, 400 volts. Let's give him the capacitor test. I think that's a good idea. Come with me over here. Come over here. Okay, you're up a little high here, but I think it's still going to work fine. Okay. Now what you're trying to see is the pie opening at the bottom here. Okay, what's it going to do? 50 volts. Oh, it opened up. A little surprise. Okay, 150. Not going to open. So this is, for me, a comparative test, comparing this capacitor to the hundreds that I've done already, tested like this. This guy would rank as, he's bad. And based on what we saw happening in the radio so far, he's bad enough in this position to cause a 1 volt grid pressure that shouldn't be there. Okay, that's good. Now, I'm going to put a new 0.01 in there and we will test for that voltage again. But remember, coffee break. I better not forget my coffee break. Okay, got the new capacitor in. Let's give this radio a test. Just going to raise the supply voltage a little bit. Make it 115, that's good. Okay, 60 volt scale. What we're interested in now is the grid voltage relative to B minus. B minus is here. Zero. Did you see a little jump in it there? No, maybe that was. Well, we'll give it a moment. Is it even a brand new capacitor is going to have some kind of leak rate in it. We're talking tiny amounts of charge now. Okay, watch that voltmeter. No, it likes the 0. That's perfect. That's exactly what we wanted. We'll double check the cathode. 6.5, and I've got the right supply voltage. A touch low, 110 here, just a touch low. Perfect. Good. Okay. I think that's going to be it for today. A simple job. Good result. Turn the power off. Hey, why don't we play this radio for a second? It is upside down, but I think we can still understand what they're saying. Oh. That's good. Let's try 590. Beautiful. When did it get that much better? might be 680. It's 640. Let's look at the accuracy of the dial here. Oh, a little problem here. Okay, let's do this.
Westland Insurance is growing its network of locations in our community to better serve your neighborhood. Our core value is to build trusted client relationships, listen to your specific insurance needs, and navigate a plan together that suits your lifestyle. Whether looking
We're listening to 640.
or assessing your existing policy, trust the experts.
These dots are just a little easy to
For all insurance decisions is our mission. Discover our services
This
offered
one
at
here.
westlandinsurance.ca. We've got you covered.
Well, I would say this is 6. It's right on 6.5 or just below. And this other one must be 70. The camera upside down. I'm finding it difficult to point at things. So, okay. That's good. That's pretty close to 640. That's just about as close as you can get, in fact. Really. Excellent. Very good. Very good. Okay, so that's it for today. I'm not going to do any more work because the sun is shining. I should be outside. That's where I'm going next. Cut this power off. Very good. Okay, well, thanks a lot for watching. And tomorrow, I think we're going to fiddle with this big fat guy here. See what he's all about. Although, you know, the radio's working really well. Should I really do anything more to it? See you tomorrow.